Hi, Kris. Thank you for joining us today on the Open Source Observability podcast. Kris is the co-founder of Inuits, Ollie, and DevOps Days, which is a popular global series of DevOps events. He's also one of the founding instigators of the DevOps movement. So, Kris, can you start by telling us a little bit about how DevOps Days started and how you've seen the DevOps landscape change in the 15 years since?
Oh, how DevOps Day started. That's a story that's been a while. So ages ago, if you have a movement that started 15 years ago, every story you start telling start with ages ago. Ages ago, I was going to a lot of conferences talking about large scale system administration, how to automate things, how to do operations. And Patrick Dubois was doing similar things. Uh, he was more on conference about Agile, also about more on the developer side. And at some point, we met at a cloud camp in Antwerp. Um, and we started chatting and we figured out it was a bunch of people that we knew that were in the same ecosystem, that were in the same space. Um, at that moment, we just had the crazy idea, what if we bring those people together? And what if we do something small? So Patrick had a venue at the office where he was working. He booked that for a Friday and a Saturday. Uh, we started talking to some people and we built a schedule. And somewhere late 2009, um, I think it was either the beginning of November or last week of October, but lost the exact time date. We actually had an event. Um, and it was about just short of 70 people that showed up from all over the planet. A bunch of people flew in from the States, a bunch of people came from Australia, people from the UK, and obviously a bunch of local people. And we had the first DevOps Day there. Wasn't anything big and planned. It was just people trying to learn from each other, figuring out how they do software delivery and what were the influences there. And if we look at the people that were there, it was a mix of people that were doing open source for companies already for better part of the decade before. And it was a bunch of people that were already agile practitioners and actually people who understood how agile worked and how you could um, do it in different types of organizations. Um, but not only, I mean, lots of times when people think about Agile, they think about Scrum. But we had a talk back then already how to do Kanban for operations and how that would be a potential better match. And then the third group of people, and it wasn't really three groups of people, but you saw the overlap between those people and those people's with interest was the third component that we saw was actually the early cloud adoption. People that had been experimenting with Amazon, people that were looking how to build your own cloud, how to build your private clouds, and that kind of things. And if you look at that group of people together, those three major influences, so open source, agile, and cloud, that's where the whole movement got started. Um, the format of the conferences is probably what really made it popular. Because in the morning we had single track formal sessions. We had like 5 talks. I mean, need to look at a schedule. I think it was 4 in the morning, and in the afternoon we had open spaces, which was one of the things that Patrick had copied from a lot of the Agile conferences, and it was pretty much in those open spaces where a lot of people got to really meet and discuss and learn from each other, and that experience about learning from each other, like, hey, I played with this worked for us, but it didn't work for me in this case, and have you looked at that tool, have you tried this approach on how to focus your backlog and all those things. And that kind of discussions is what really was for a lot of people the thing I was like, this really works. This is where I learned, this is where I can share my experiences. Um 2 days later, discussions started happening like, yeah, we need to do this next year. Um, so John Willis took the idea to the States. There, together with Andrew Clay Schaefer, they started one in Mountain View. The European side was a couple of people who wanted to do something in Hamburg. There were things happening all over the world suddenly. Uh, First couple of years was mostly one event on each side of the ocean, and then some more in Australia and South America. There was one, I think the second year we actually had one in Sao Paulo. And if I'm not mistaken, also in Sydney, because Lindsay Holmwood, who came to DevOps Days Ghent the first time, he actually took the idea back to Australia. And then it was in Europe, it was mostly Hamburg, then we did Göteborg, then we did Rome, and now I'm forgetting. I think that was Ghent, Hamburg, Göteborg, Rome. And in the States, it was Mountain View, and then slowly things started exploding. So by 2012, 2013, there was a lot of the larger cities with the, hey, we want to do this too. I pushed the guys in Amsterdam because I was working a lot in Amsterdam in those days to do one. Paris started happening, London started happening, and then things exploded.
It's a fascinating kind of, like, I think you said, it was sort of right at the beginning of when that cloud infrastructure was becoming a huge part, as well as Kanban and things like Agile. And then suddenly you just sort of globally saw when people were given a space to share ideas that it took off. So
Yep.
that's really interesting to hear. In the past, you've mentioned in a talk that if you ask 10 people in a room what DevOps is, they will give you 10 different answers. So to you, what does DevOps mean?
To me, DevOps really is a global movement that's moving forward the quality of software delivery, and we started it in Ghent. And that is, it's based on those values of open source, of Agile, and taking those practices. That is what DevOps really is about. To me, it's a discussion on how do we improve the quality of software delivery. All the different flavors, all the different methodologies that map in there, to me, are all under the umbrella of DevOps. Like SRE is how Google did their DevOps implementation. The Spotify model is a snapshot of a description of, at that point in time, Spotify, how they solved their team interaction problems. That's one of the other. Platform engineering is a method for a specific type of organization of how you can still build something valuable with more centralized operations teams that offer things as a service. And it's all different flavors, but fundamentally, it still comes back to how do we deploy and operate software, and how do we build it, and how do we, as different skill sets, collaborate to improve that.
I think that's a great answer, and I really like that, because there's all these terms that are sometimes used interchangeably at different organizations, but that idea that, SRE is really Google's DevOps, and, platform engineering is another case, and Spotify, also has its own model. What I really found interesting about talks you've given and, like, kind of, encouraging people in DevOps adoption is that it's about collaboration, like you're describing, and, like, kind of how things are organized, not tools. And I really love that once you said beer was the best DevOps tool of all. So can you expand about why this is important and where you think organizations might just be totally missing the point?
You've been going back really long time because it's been a while that I said beer was a
I did
kid.
my
I was
research.
doing it in the early days. Fine, yeah, but that was a really early days. And the thing is, when we joked back in the days that beer and sushi were the actual tools, that was, I think it dates from one of the talks I gave in the early days, was titled 7 Tools for Your DevOps Stack.
Mm.
And during that talk, I was going over all the fancy tools that we could use. But the gist of that talk was really, it's not about those tools. It is about the humans interacting. And where do you remove a bunch of the barriers for interaction? And where do you get people to sit down and to talk together? Well, that's if you give them food and drinks. That's when they start chatting. That's when they start talking about things. And it's not always in a meeting that you get solutions. It's sometimes in the events after the meeting where you get those discussions. And yeah, the joke's been running. Belgium has a great beer culture. A lot of the talks we did were abroad, and we were joking like, yeah, if you want people to start talking, give them a beer. Um, in other events, it was like, yeah, give them sushi, because then they'll start chatting also over food. So it was kind of to give them that trigger of getting that communication going. The other thing we put at some point in there, like if you have a team, a fresh team, where people suddenly from different skill sets are being put together, like you put ages ago was well, not ages ago, because still in a lot of organizations, there's the operations teams, there's the developers team, and they don't talk to each other. And if you put those people together in a team event or you do something together with them and you give them too much strength, then they have one common shared thing the next morning. That's a hangover. And they can start chatting about their hangover in the morning. And it works. It's probably not the best advice, but it works.
Yeah, no, and to kind of expand on that, to try to reduce the silos, because you had a great point about like that's what DevOps is not supposed to be, is this third silo. Other than having like good company culture, events, making sure that there's interactions between the development and the ops teams, DevOps. Is there anything else that you would recommend to kind of improve that communication and reduce the siloing that organizations can adopt?
It, it comes down to a lot of cases that managers need to stop micromanaging and need to start trusting people. Um, Servant leadership is a term that has been popping up a lot of times, but the old command and control, you need to build this by then. That's something that Agile already has figured out that that's not going to work. You need to have the feedback loops. You need to figure out what's working, what's not working, and get that early feedback on things, both on development and operational sides. And that level of, you need to be able to have people own what they built. And once they own what they built, they're going to actually start caring about it. And they're going to get to that point where you get cross-functional teams that are self-organizing, that can build something and be proud of what they're built. But as long as there's somebody on top says, yeah, you need to do this by Monday, and the person who gets that order has no clue why and what he's building, he's not going to get to that feeling of, yeah, I'm proud of what I'm doing. No, they're just going to be in the mindset of, I got a job. It's started at 9 on Monday, it ends at 5 on a Friday, and I write code, and whatever happens with that code, they don't care about. But once you turn it around to, hey, this is where we're building, these are the people that you're helping to do so, and they see the value of the work they do, and you give them the power to improve that, that's when things start to work better.
I think that's a great description. Is when are you empowering an engineer to learn, or do you want him to be a bureaucrat? And that's going to affect the quality of your software afterwards. Kind of in that bracket, I wanted to ask because there are. I want to get into the tools later, but you said in the past that sometimes enterprises will, like managers especially, will run to say, "I need cloud, I need Kubernetes, or something fancy and new," and the organization doesn't actually need that. It's probably case by case, but do you have any general advice for, okay, we would actually need like cloud infrastructure? Like when would that be a case, and when are you probably just a mom and pop shop and you don't need to be adopting these tools?
The when do you need a certain tool has evolved. Like 10 years ago, I would say, unless you really need to be able to scale out and to have on-demand compute power, which you cannot really predict, you don't actually have a need for cloud. Like today, I'm saying, look at the cost, look at where you want to host your things, um, but still look at how to use it. Still today, we're seeing a lot of people just doing lift and shift and drop their data center stuff the way they have been deploying it for the past 10 years, and they put it on public clouds, expecting that it's going to be cheaper. Well, it's not. It's going to be different. You're going to do different things. But a lot of organizations don't understand that if you keep the forms in front that a user has to fill in, and then somebody else is going to provision something, but now it's going to be on a public cloud, that is not really cloud adoption. But that is in a way what a lot of corporates are still doing. They've now moved their workloads from a physical data center around the corner to a third-party managed data center with an API that they're still not showing to their end users. And the power in cloud adoption for a lot of things is giving that freedom to the developers, to the, in this case, end users of that service, to do what they want when they need it. And a lot of the failed cloud adoption projects, which make it much harder, is not giving those people that freedom yet, because the old ways, because command and control, because the trust isn't there. If you're still in that kind of organization who has that kind of approvals and policies that they fail to automate, then don't go to the cloud. Stay in your own data center because it's not going to help you. But apart from that, the cloud has become to a level so easy. I mean, it would be stupid to start building your own data center, racking your own machines, unless you have a specific need for that.
Okay, so it's actually the other.
That doesn't mean go to the big vendors. There's a lot of suppliers out there. There's a lot of options out there. It doesn't have to be one of the three big ones.
Interesting. Okay, so it's actually the other way around. That in most cases, that adoption is fine, especially if the automation processes are there. I wanted to back it up because we keep coming back to this command and control and owning your work. So I wanted to ask you, when did you sort of discover open source and what attracted to it, and just to talk a little bit about your role in the community and why you like it.
When did I discover open source? That must have been 1990. When did the Linux kernel got released? 1993?
It's like 90s. Just a small project.
Around-
Won't be big like GNU.
Yeah, that one. And about a year later, I think my first Linux installation was 0.94 something. And I was using DOS back then, MS-DOS. I never did Windows at all. Did a bit of desk view, and then I moved to Linux completely. That's when I started doing all kinds of stuff. Writing documentation, contributing to the OpenMosix project, which was a single system image cluster platform back in the early days. I was a release manager there. Then I started doing more database stuff, doing a lot of different communities over the years. And it was just something that I felt comfortable in. I just couldn't work with proprietary software because it didn't work. It didn't.
Right, go ahead. No,
Every time-
I'm in agreement. I think it's great. It's just fun when it's not only ideological, like it's important to you philosophic, but it's also like, hey, this code is just better when we can all work on it together. That's a great point.
Absolutely how we started out. I mean, back in the early days, the speed at what Linux was being developed and the speed at which other open source tools were being developed, they were actually building the reference implementation. And they were actually showing the world how software was built at a distributed scale. And then if I had to work for some reason for a customer on some other platform, while it was breaking always, the only way I could get support was to call a help desk that didn't understand the actual problem, that escalated the problem 5 times, and not 6 months later, you still had the, hey, by the way, this issue is still not working. And then they closed the issue and you had to file another issue because, well, it still wasn't working. And those were the large Unix shops. That was Sun Microsystem, that was HP. And on the Linux platform, I got a new hardware, I got a new network card. I figured out what was the actual hardware. I talked to a bunch of my friends, and a couple of hours or a couple of weeks later, we actually had it working because we had the specifications and a group of people together worked on it, and we had support for the hardware. And that was a community that started building the internet. At some point, there was the battle between Microsoft and Linux and all stuff, and we joked like, okay, fine, cool. What if you turn off all the Windows boxes in the world? Are you still going to have mail? And people were like, nope, you won't. So which is the most important part? And at that point, it was clear that open source had won. And I still, till today, cannot figure out how you would build software in a different way.
Yeah, I think that's a great description is that if you don't have that openness, you're not really going to have, without collaboration, you can't have proper innovation. So I think that those are all great reasons. I wanted to go back and dig a little bit in because it sounds like it's a huge part. So how would you define continuous integration and continuous deployment philosophy? And what are your best practices for properly implementing it?
So it basically goes down to the very definition of continuous integration. That means trunk-based development. That means that developers are constantly, well, theoretically at least once a day, but best constantly committing to trunk. Whole discussions about branching and stuff, to me, there's no discussion. There's trunk-based development. You don't branch unless you really, 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 really have a good reason to do so, which in most cases is misunderstanding that it's a totally different artifact that you're building, or not understanding how collaboration works. And once you get to that, if you have your test automation in place, if you have sufficient test coverage, then you get to a point where what you're doing is continuous delivery. Sure, there might be humans involved that still say, yeah, looks fine to me. But getting that single automated path to production, that is what it's really about.
That's perfect. You said merge hell once, and I wanted to ask you what that meant. So it's basically branching, like when you're not supposed to, and then screwing up the code base with it.
Yeah, it means that people think that creating a branch is going to help them with software delivery. And what typically happens in a lot of organizations is, yeah, we'll do short with branch. And then you ask for the question, what is short? And depending on the maturity of the team, they go from short-lived is, yeah, it's going to be gone by the end of the day because it's just me hacking on something, till larger organizations would say short-lived is the time of a sprint, which then could be 2 weeks or 3 weeks or 2 months, or short-lived is a quarter. And you go like, no, that's not short-lived. But that means at that point that people are writing code, they're not testing the code, they're not integrating the codes. And at the end of the sprint, they look at it and say, or at the end of the quarter, they look at it and say, okay, now we're going to throw all of this together. And they've modified parts of the same functions or files, and it just all breaks down. And the worst I've had with a team that didn't want to do Tron-based development was they worked for 6 months, and then they had 6 weeks they spent on actually getting things to compile again.
Oh God. Yeah. And then you can have issues where I can imagine if you've branched something and you merge something that no longer reflects the current code base. There could be a bug in this one that now gets brought back.
Exactly. And then you basically spend so much time figuring out, how did this happen? How did this happen? And the whole thing is, people think that because open source projects do it, this must be the right way. But the philosophy is different. If you are an open source project maintainer and you have a code base on GitHub, and some random person whom you've never met, whom you never talked to, says, hey, here's a fix for this, or here's a new feature, that might be something that you say like, this is literally the opposite of how we are implementing this, or this is a feature we don't really need, or, well, we're actually planning on building something that does it totally different. So you, at that point, want to have that discussion going up. It's like, yeah, maybe it's good, maybe it's perfect, maybe it's what you want. But you don't want them to just commit straight into your code base. You want to get a conversation going. However, when you are an internal team within an organization and you say, we're running this service, we're building this service as a team, you have a couple of meetings a week, a month, where you talk about what you're going to build. I mean, I'm not big on all the ceremonies. You do the ceremonies that you care about, so you can do your sprint planning, you can do your stand-up, but at some point, you're going to have that chat. Hey, this functionality, we're going to build it this, and this way.
Mm.
You've already agreed that, and you should be capable of trusting the people in your team. So what is the value of then sending a pull request that actually says, yeah, well, this is what we discussed. Can you still approve this again?
Oh,
Apart from waiting, it basically blocks people again. So creating that feature branch, sending a pull request with an internal team that should trust each other, that should already have agreed on how they're going to do things, is a waste of time. If you have something that say, well, this is a bit complex, I'm not really sure, go sit together. That's the perfect moment to do some pair programming. It's going to go faster eventually, and you're both going to learn. And I used to be pretty drastic on saying no pull requests ever. The thing that over the last couple of years, I kindly said, okay, this is a case where you could tolerate it. It's like you have a new member to the team, typically a junior or somebody who comes from a totally different organization, and to get them to build up that trust, like for the first couple of weeks. Yeah. That's when you can say, hey, you don't trust yet yourself to do this. We want to help you. You know what? For the first couple of weeks, you really want to, you can send a pull request. We'll review it. And then, but once you get to that comfort level where, well, we kind of expect you to have reached that level now, then the pull request is just blocking. If you look at how organizations work with pull requests, it typically, like, a developer is working. If you send a pull request, they're not going to respond to it immediately, because if you get a developer out of his attention span for 5 minutes, it basically means he loses a lot more than those 5 minutes. So they're not going to be instantly responding to, yes, that is a good proposal. The other part, so that's already one place. The other part is, like, if you have a pull request and it's like 200 and 400 lines, it goes like, somebody go over it, go like, yeah, looks good. But they're not really going to read the code. And if it's like a 3-line pull request, they're going to look at it and say, I would do that bracket of another place, and this is not up to our coding standards. And the whole thing about this is not up to our coding standards. Well, there's linting tools and other tools that are actually going to tell you already, this is the coding standard we use, this is what you should be doing, and fix this coding pattern. So there really isn't any value within an internal product team to have a pull request,
I've never heard it
except for micromanaging and bureaucracy.
Yeah, that's what I was just going to say. It's like I've never heard it described as like a pull request as bureaucracy, but now that you've explained it, I can see why organizations want to consider why they're doing this. An unnamed organization, I've had a friend say, a couple of us buddy up at work and we'll just approve each other's, which is terrible. Like, don't do this. Why are we doing this? So that's really interesting advice for organizations. Maybe consider how you're structuring this. And I also wanted to ask, because different organizations will use different methods. When should teams use Agile? When should they use Waterfall? And does it matter?
Waterfall, if they're not doing software and stuck somewhere in the late 60s.
Okay, so it's gone.
For me, it's gone. I've never seen any successful waterfall-based software development project. If you can really predict what you're building, like if you're building a house and you need equipment and material, and you say, my team can build this amount of square meters of wall per hour, and you can perfectly plan it, sure, that's something you can do with Waterfall. But you need to do something iterative with software. You don't really know what's going to come next. You have a general idea, but you're doing constant research. And then you need to go back to your developers and your users saying, hey, is this what you really wanted? So you want to have something iterative with fast feedback loops. And that means telling your organization, like, hey, this is what it looks like. This is something that we, within the next couple of weeks, within this time frame, we as a team can actually commit to building this. And we're not going to overcommit, and we're not going to say in a waterfall organization, yes, we need this done in 6 months, and then the developers do things, and 6 months later it's completely out of sync. No, we assume that we can do this in a week, in 2 weeks, and then we're going to come back to you and say, hey, is this what you wanted? And at worst, you've lost 2 weeks. In a waterfall approach, they've done 6 months of analysis. They've then built something for a year. So that's already 18 months they lost. And then they're going to go to the business owners and the customer. And the customer is going to go like, yeah, but this is not what I wanted. And you've wasted 18 months.
That's okay.
Because you cannot predict those things. You don't know really where you're going. And things move at such a pace. I mean, within the software world, I think Waterfall, and that includes the fake Agile improvements, like scaled Agile framework, whatever you say about it, that's the best Waterfall implementation you can get, but it's nothing to do with Agile. That's still command and control. You're going to deliver this within 3 months, and then the teams internally get sprints and stand-ups, but they're not Agile.
It comes back to everything you've been saying about communication. Is with Agile, it sounds like there's consistent discussions with the customer with like, is this what we should be building? As opposed to, let's perfectly plan this out. We go to the customer a year later and then it's all been wasted time because this is not what we need. So that sounds like,
Exactly.
yeah.
And that piece of communication, I mean, the Agile movement in the early days, what there started, the Agile Manifesto for Software Development was really about bridging that gap between the developers, the people that build the things, software developers, and the business. In the early days, what did we say from the DevOps point of view? Well, hey, here's the ops folks, you forgot us. And it was one of the approaches that was being put out there as, yeah, DevOps is about software development, but now include the ops people, because Agile solved the bridge between the developers and the business people. And it was an extension. That's also in a lot of cases why we say that, well, don't start with adopting DevOps if you're not really capable of doing Agile development yet. But on the other hand, well, if you are going to go on that journey, don't forget the ops people, include them first. And when we say the ops people, it's all of them. It was never meant to be not the security people, not the DBAs, not the storage people. It was always everybody involved in running things and keeping the lights on and getting that communication going. Because what we saw later was, the DevSecOps movement. What do you think? You weren't included? Sure, you were included. I mean, in 2011, we were doing talks at OWASP and why they would be included. DevOps Days Amsterdam, one of the early years, there was, forgot his name, Frank Buytaert, who was talking on stage. He's now a security officer at Sherbrooke Phillips in the Netherlands. And he was like, yeah, what is DevOps? It's like HTTP. Without the S, it's insecure. And that was already the early days. So naming things is hard, but it really was about everybody you need to get software delivered and running from inception moment till the moment you decommission it.
Really interesting. And how do we get them to all coordinate and collaborate effectively and talk to each other? You mentioned once that you hate certification. I think for Scrum, maybe is this just sort of like do not memorize it, do not read a book, and then pretend that's going to work. So, what are your recommendations for like how do you learn how to implement it on a case by case basis where it's going to work in an organization and lead to effective software delivery?
Try it.
Sure, go ahead.
Do some experiments, see how that works for an organization, and go back. If it works, take the next one. If it doesn't, adapt. My hate for certification, it's mostly comes from a lot of the certificates that you see in the commercial world are you buy this product, you get the training, and then you can do the exam. And it's always get more revenue. Like, okay. I literally at some point was in a training for this has been ages ago. And at some slide, the tutor literally said, this is an important slide because one of the questions in the certification is going to be out of this. And it was basically the core principles of the company. And the correct answer you had to fill in the certificate is we respond to email. And you go like, exactly. And then you go like, okay, so it's a multiple choice, and the correct answer of the values of this company is we respond to email. Like, what's the value of this certification? There's been obviously exceptions where people really had to reach a certain skill level. And then we come to DevOps certification, like, how are you even going to validate that somebody knows what they're talking about and does all these things? So DevOps Days Berlin started making a joke out of it. They put their registration badge, they made that a certificate, and then in I think it was the 10th year anniversary or the 5th year anniversary, or the 5th year anniversary, we also made a joke out of it, and we basically gave everybody who came to the conference a certificate. The Berlin folks got us, however, because they said, yeah, you need to renew it every year. You need to come back to the conference.
That is funny. So practice basically is your recommendation, and wary of it. Like if you want it for your LinkedIn, that's fine. But to actually be good at it and be good at what you do, go practice, go talk to people, get to know people in your team. I wanted to switch back over to observability. So observability, you said in the past, will not fix your broken monitoring. So for any like new DevOps or SREs, can you define how those two are different and what broken monitoring they need to fix before they start going and adopting observability?
Okay. How they're different to me is, it's a layered system. People talk about the three pillars. They talk about monitoring, they talk about metrics, logs, traces. To me, it's layers. You start with basically health of your system. Is this thing still on? Once you get that correct, you go to a next level, which is metric based. And metric based is different depending on your ecosystem. Like if you are an online vendor 24/7, it's different from your local enterprise that is only office hours, because you don't have the different set of data, you don't have the same size of data. Where in an online world, if you suddenly go to 0 requests, that's an anomaly. In an office world, if you go suddenly to 0 requests, well, that's Friday 5 p.m. That's expected behavior. So you need to deal different with those. And a lot of people have gone from, we're failing to actually do the health checks, let's turn it over and let's do the metric based, not understanding those differences, not understanding that the way they are measuring things is not per se failing or working. And what happened there is that people kind of start to figure out, hey, the health check, that's a 0 or a 1, right? So now we have a metric, 0 or 1, and a 1 is good and a 0 is false. So that was one part. Difference between metrics and health checks. The other thing is, most corporates, their infrastructure is not automated or partially automated. There's still a couple of things they do manual. They don't have, well, if they think about how they do infrastructure management, if they're still thinking about how to do ITIL, there's nothing wrong with ITIL apart from the fact that it also got abused by a lot of people. But there's this thing about the CMDB. You're a centralized database, which actually should be a single source of truth of what your ecosystem, what your infrastructure looks like. For most organizations, that doesn't exist. It has been crafted manually. It's completely out of sync. It's multiple sources of maybe. If you run an infrastructure, what you really want is that single source of truth that says, we're running these, and these services. They're up to date. These services compose of these subcomponents. These are the things you need to monitor. Somebody provisions something new, automatically your monitoring is being updated. And when you do infrastructure as code correctly, you get those things out of the box.
Okay, so it sounds like, yeah, single source of truth, and then also don't have a cookie cutter. Understand, like, if are you a 9 to 5 shop, or are you huge enterprise,
Yeah.
and get those ducks in order. You mentioned pipeline as code to talk. What's infrastructure as code?
Infrastructure as code is basically that you write code like ages ago. I would see Engine. Then we started doing Puppet, Chef, Ansible. Then we moved to, well, depend on what you want to provision. You move to Terraform, Pulumi. Well, these days OpenTofu rather than Terraform. But those languages actually define in code what your infrastructure should look like. And infrastructure is basically, to me, it's everything you need to run an application. So with infrastructure as code, what you do is you say, hey, this is the code base. It's stored in Git. There's a pipeline or a tool that takes that code base and actually applies that code somewhere. And that code spins up Amazon instances or boots up bare metal instances, builds a database, builds a storage, builds whatever you need. And it does that over and over again. So when you change something, it gets updated. You change the code, you provision a new web server. The new web server is being provisioned. And because that automatically is registered in your single source of truth, your monitoring can then dynamically be updated and you get up-to-date monitoring. And the problem with most organizations is they don't have that mechanism. So what they're monitoring is something that was up to date yesterday, but won't be updated in 2 weeks. So when people either spin up new services or they decommission them, you still get alerts or you don't get alerts, or people forget to configure the monitoring. That is a fundamental problem you need to solve before you get to the point of, let's take that next step and now figure out how is my application behaving, because now I can get to the level of having better metrics, having better resources in place. And then even a next level is, why is it behaving this way? And when you reach that level of why is it behaving this way, that's when I start talking about observability.
Okay.
Like figuring out how is things happening. But most organizations, they have alerts all over the place. People are being paged at night for things they really shouldn't be pulled out of bed from. And they're not fixing that. And in the meantime, they're trying to build a huge complex stack with a lot of components to give the developer that small little bit of performance increase. And oh yes, if they're really doing it wrong, they doing that observability tools that's going to work only on their specific Kubernetes instance and not on the rest of their ecosystem.
Oh, so it's not even.
And that's why people really need to take that step back and say, hey, before we start spending time on this really small part in our infrastructure on observability, we need to get to the point where our ops people are happy. The developers are fixing the bugs that need to be fixed so that people are being pulled out of bed at 3 a.m. when things break. We need to get to that level first, and then we can start improving performance, improving quality, and all of those things. How do I go from just the tool that looks at this really small bit to how do I look at the whole of my ecosystem, taking all the different components?
Yeah, understanding the picture, and then making sure that also you're not pulling that SRE out of bed at 3 a.m. to make sure that you can deal with it.
Because when you Till that is a re out of bed at 3 a.m., it eventually just becomes a service restart engineer and not a service reliability engineer.
With that, I kind of want to segue with how did you discover Coroot and what do you like say when people have the why in place and they want to, and it's open source, which is also in line with your values. What do you like about Coroot is kind of helping them get to the next step?
So I was looking at tools that would do eBPF based stuff and ODel stuff, but not only on Kubernetes. Because like I just said, there's a bunch of tools that do this thing on Kube, but my ecosystem and most customers' ecosystem is like there's a Kube cluster there, there's a database cluster there, there's a lot of applications that are running not in containers on the rest of the network, and they talk to each other. And when you look at the problem that's happening, it's not going to be just within our one isolated cluster. It's going to be somewhere. So I was looking for a tool that was doing eBPF, but not only on Kubernetes. And then you didn't have a lot of options. So I ended up playing with Coroot, and it was like, it worked. I could spin up things really fast, and I could see things really fast. And it was open source, so I started liking it and started playing with it. And it ended up being a tool that... So before that, what I was doing was I was trying to get Prometheus to a level that was on a fully CMDB-backed Kinga-based monitoring, good alerts, quality alerts, and I was spending a lot of time. And then you need to set up Prometheus, you need to set up distributed storage setup for that, for the retention. So you need something like Thanos or Cortex or Mimir. And then you still don't have traces. You need to put up an OTel gateway, you need to put up Jaeger needs an Elastic backend. And before you know it, to build an observability stack with a lot of components, there's like, whoa. The next question becomes, who's going to pay for the whole stack? Because we need so much compute and storage and then you need the engineering team to run it. And I was like, if we need to get this deployed, implemented into larger organizations, it's going to be expensive. And a lot of those organizations wanted to have things within their own boundaries. Europe, definitely, things like sovereign cloud are getting more and more important. Shipping your metrics, shipping your data to some US vendor, really not an option anymore. So people wanted to have something that they could build, that they could run. But the complexity in doing so was huge. And Coroot solves a lot of those problems. Sure, you still need a ClickHouse backend, but as long as you don't need it for long-term storage, it's not that complex. You can limit it to 1 or 2 days, and the volume is going to stay as small as you want it to. But it gave me freedom to play with things, with tools that I knew, with frameworks that I knew, and it gave me results pretty fast.
Interesting. Yeah. So it solved a lot of those issues. And yeah, the data sovereignty thing, it's great that it's kind of able to help with that for people that want to achieve that as well. I have a couple more questions kind of about observability. So what would an observability anti-pattern be? And what are a few common examples to avoid?
To me, an anti-pattern would be that you actually get alerts from it.
Mm.
Because a lot of those alerts are not actionable. A lot of those alerts are insights you want to know about, but you cannot really do something about it immediately. Like a third-party API that is slowing down. From an how's my application behaving point of view, that's important to see where potential issues are in your application. But the fact that you get an alert on that, what can you do about it? Not a lot. But still, you see people who have all of those alerts active, and there's somebody in the team who goes into acknowledge, basically wasting their time creating alert fatigue. Because the actual alert that you do care about one of your internal components slowing down, they're going to miss that. So that is definitely one of the anti-patterns that I've seen. The other anti-pattern that I've seen is people who implement all the tools. And that is an anti-pattern that we had already from ages ago. So they've implemented 4 or 5 different tools, and now they're trying to figure out which tool to use when. And they don't know. It happens when you have a tool that only works on Kubernetes and a tool that only works here. Then you need those different tools, but you still don't have that holistic global view of what's going on. So that is definitely also the other one. Thinking that your vendor knows what they're talking about, and then I'm talking more about auto instrumentation and that your application will actually dynamically be detected as this is your business functionality that you want to monitor. It doesn't work. You still need to instrument if you want business functionality to be traced or monitored. You still need to do that. At least I've not seen tools that did that out of the box. But a lot of vendors say, yeah, no. And then you ask them, you drill deeper and you say, can you do this? They go, oh, no, that you cannot do. So a lot of the demos look really nice. And that's where the purchasing department says yes. But when you eventually start doing it, it's like, oh, no, that doesn't work. That was a nice demo. But that works on a demo application because that demo application has the instrumentation, but not on your application. So that is definitely also a caveat that people drop into.
Interesting. And I wanted to ask, because you used to have a blog called I think it's always a freaking DNS problem, and it's
So the actual title of the blog is everything is a fucking DNS problem, but I changed it to freaking.
conferences you couldn't say it.
But I changed it to freaking because apparently because the fucking words, it was being blocked on a bunch of corporate networks. Yeah, people said, hey, I can't read your blog. Like, okay, then use this feed, and that worked. But that's something that already from has been up there for what year is 20? We're almost 2026, so ballpark 20 years. When I
I just wanted
started it,
to ask, because I see this joke everywhere kind of too. So can you explain from a technical standpoint, why is it always DNS? Why is that always what?
because people misconfigure DNS all the time. So DNS as such, the binaries, the services, they're rock solid. They're not a problem at all. But it's the node misconfiguration and client implementations. And misconfiguration to the point that people try to resolve a host that doesn't exist. People update the DNS configuration, but forget to update the serial number. So they're still talking to an old. There's a comma, there's a dot missing at the end, so that the completion doesn't work. People expect a host to be there, but it doesn't exist, and the client library fails to say what's really happening, or people actually forget to have correct error handling, like error host not found, but they keep trying. That's kind of things that were happening a lot with DNS implementation. There still are. So when DNS then also points you to an old host or the wrong host, then you definitely have problems. You could be querying the wrong database, you could be querying a wrong endpoint. All those things happen. And I was at some point, somewhere early 2000, probably debugging so many of those problems that I've shouted out, hey, everything is a DNS problem, up to the point where I actually made t-shirts I had printed on the back. So I had t-shirts with everything is a freaking DNS problem on the back of my on my back, and people came up to me. They wanted to ask a question. They read my t-shirt and went back. And then half an hour later, when we were grabbing a coffee, they said, "You were right." Like, well, I was right. What? Yeah, I had a problem. I came to ask you for help, and then you said you didn't even say it was DNS. I went back and it was DNS. Like, okay, and that was 20-something years ago. So I had a title. There, a bunch of people started saying so, and then people started pointing at me. So yeah,
That's funny. So it's just really easy to fuck up, and it's still really easy to fuck up. So, if you're having an issue with your
but most of the time it's human error.
yeah, human
Error broken client library. Like one of the things where it really was a broken client library is high availability over DNS. If you put an A record with 2 IP addresses in it, some resolvers actually load balance over it. Others just take the first one that works and never actually update it. They only take one field, which means that if your first server went down and you had that as high availability, it never worked because when it was down, it was still resolving to the old address. And that was a client library implementation. But explaining people that using DNS for high availability in that way, they were like, nah, it works on my machine. Yeah, it works on your machine, but you don't have control over all the resolving library clients that you are supposed to be using. That's operating system dependent. You don't know how that's going to work. So those are all the little nifty details that it's a fun ecosystem. But it in most of the time was human error.
It's a good takeaway. I'm gonna say we got through like a lot of really interesting things that I think are gonna be really helpful for new DevOps engineers. My last question, because I did not want to make this about tools, it's about people and not tools. I still find the technological evolution of DevOps interesting. And when we started this talk, we were talking a little bit about the beginning of cloud computing. Can you describe the big technological shifts that have changed DevOps and especially Kubernetes? Like, why was that so monumental and kind of being a big shift in the DevOps movement?
So Kube wasn't a really big shift. Um, Containers were,
Mm.
because containers were what we were doing before that was we were providing developers with, and even containers weren't. Um, so what we were doing is we were providing developers with something that really, really looked like production. And we were using tools like Vagrant, and Vagrant was spinning up virtual machines for them locally, and it was heavy and it was slow. And then we started playing with containers, and it was still complex for the developers to use. And what really made things easier was that abstraction layer that Docker gave people. But there also was a gap that now a lot of the things that we learned, like how do you build an infrastructure, was something that was abstracted away, and developers at some point assumed that they could do it themselves,
Mm.
forgetting again all the lessons that we had learned over the 10, 15 years before. So Docker kind of made things easier for developers, but again, put a lot more pressure onto the operational side, because running containers locally in your machine is something different from running containers at scale in a data center with a lot of network complexity around it. And then Kube popped up and claimed to make that abstraction layer easier. And if you look at Kubernetes as an API framework where you can build in things, it's really awesome. And it's something that really has moved us forward. But if you look at it as this is going to make running containers easier from a developer point of view, yeah, probably yes. But from an operational point of view, no. It just made things much more complex. And for a lot of organizations, the things they failed to adopt when they moved from their own data center to the cloud was things like, where do I use storage? Where do I store my data? How do I deal with databases? They didn't change those patterns. They just did lift and shift. So what they were doing still was having a Java application that was writing locally to files on the file system. That works if it's your server and if you know that it's always going to run there. That doesn't work if you're in the public cloud or in a container and you don't know if that server is going to still be there in 2 hours, or if that container is going to be respawned on another node. So you need to write your software differently. You need to adapt the way you architect your software. And the problem is that a lot of organizations still have not done that. So when those things happen, they lose data. Except if on an operational level, you start fixing things, but then you just made things more complex, because then we've added layers and layers and layers of complexity, and now we need to figure out how things work. And then you need to skill people again that know how the stacks underneath work and where things can actually break. And in a lot of cases, well, it's DNS. It's core DNS that's respawning.
That's really fascinating. So as it's kind of developed technologically, like it's good for developers, but it gets harder and harder for ops. And if you don't have that organization, that kind of culture and everything in place, these technologies are just going to make things more complicated. They themselves are tools, not solutions, I guess is another way to say it. So that's an interesting takeover. Okay, perfect. I'm going to say on that, thank you. So it was really interesting to learn about. So thank you so much for sharing all your knowledge from being an open source community leader and instigator of the DevOps movement. Kind of before we head out, just tell people any events where they can go see your talks, where you're going next, and anywhere, if you want to be found on social media, anywhere they can go find you and talk to you.
I've don't have any talk scheduled. But it can meet me next is FOSDEM in Brussels, and then 2 days later we're going to Ghent. We run Config Management Camp there. Config Management Camp is one of my other conferences. It's the largest open source infrastructure automated conference in Europe. And actually, honestly, I don't know any one that's bigger in the US either. We about 600-700 people who come there every year. This year was really fun. We had more than a quarter more talk submissions than last year. So if people think this ecosystem is in decline, no, it's growing. It's really interesting to see that. Um, and yeah, my social media I'm mostly active on Mastodon these days. Bit of read only Blue Sky, but doesn't really do it for me. And that really is about it. Um, so yeah.
Okay, perfect. So I'll link those in the description so they can go find the event and go talk to your Mastodon. And thank you again for sharing your knowledge with everyone today.